You're welcome once again to another exciting video lesson on Maestro Science Guide. If you are just seeing this page for the very first time, this is a science YouTube channel where you learn chemistry, biology, and physics, alright, the most easiest and the simplest way. Okay, now in today's video lesson, we're going to be talking about physics, alright, and specifically, we're going to be looking at the beginner aspect of physics. Are you getting it? The beginners what aspect of physics. Now there are three areas that are actually beginner levels. All right. We have the area of the dimension. We have the area of fundamental and derived quantities, and then we also have the area of motion. These three areas are very essential as fundamental areas, and we're going to be concentrating first on these three areas. All right. So today's video will be on one area. Then another time we are going to treat other areas. All right. Now in today's video lesson, before we even begin, before I introduce the area we are going to go into, first of all, what is physics? Now take note, physics is the study of matter. Physics can be defined as the study of matter with relation to heat or energy. Are you getting it? So physics is the study of matter with relation to heat or energy. The study of matter with relation to heat or energy is called what? Physics. Are you with me? Alright. Now moving on. This is what physics is all about. Now the aspect of physics we are going to be starting off with first is on the area of fundamental and derived quantities. Fundamental and derived what? Quantities. Fundamental quantities are simply called basic quantities. What do you mean by basic quantities? They basically don't have where they are getting from. They just, they are the most foundational. You cannot get any other quantities, or they are not gotten from any quantities. All right, they are quantities themselves. Okay, so they are the ones that give rise to other quantities, which are known as derived quantities. All right, so now what are examples of fundamental quantities? These are areas where you need to pay close attention to, especially in examination conditions. You see questions from these areas. Now, examples of fundamental quantities. So, firstly, we have length. Next, we have mass. Next, we have time. Next, we have light intensity. And then we have temperature. So now, what are their units? This is another very important thing you need to know. So the unit of length is meter, the unit of mass is kilogram, the unit of time is seconds, the unit of light intensity is candela, and the unit for temperature is Kelvin. So it's very essential. Let me just write them in full. So we have kilogram, we have meter, and then we have what? Second. The fundamental quantities. All right, we also have one more fundamental quantity that I've not added. One more fundamental quantity, which is what? Current. All right, current, and the unit is ampere. All right, so these are the six. 1, 2, 3, 4, 5, 6. These are the six fundamental quantities. Then for derived quantities, what are examples of derived quantities? We have density. Derived quantities are basically those ones that are gotten from the fundamental quantities. All right, so any one not part of these six is derived quantity. So derived quantity is the quantities that are gotten from what? The fundamental. So e the density. Now what is density? Density is mass over volume. Remember, mass is what? Under fundamental quantity. So then you will be asking, like, how come volume? Is volume then a fundamental quantity? Now, hope you know that volume is same with length. Alright? Volume is very similar with length. Okay? But I'll show you the similarity. It's not really like the same thing. But volume still talks about length. Alright? So if you look at this, length or okay, let me just length is L, area is L times L, and then volume is L times L times L. That length is just length, area is length times length, volume is length times length times length. Alright, so thereby our unit for volume will be meter cube, area will be what? Meter square, and then length will just be what? Meter. So you can observe the similarity, right? So good. So that's why density is what? A derived quantities gotten from this. Okay, then what would be the SI unit for density? Becomes what? Kilogram per meter cube. All right, so we also have other derived quantities. We have pressure. Let's not waste time. So we have pressure. We have um, um, many others. We have um, many others. We have impulse. And if we talk about impulse, we can talk about acceleration. Acceleration. You know, even velocity. All right, so all of these they are what? Derived quantities. Okay, so any one or part of this is not all. Okay, this is not all, but for fundamental, this is everything that is generally accepted as fundamental. Therefore, derived can be more than this. So just know your fundamental. Anyone not among these, all right, is what? The derived quantity.